Here we go. Okay. Morning, folks. Hope you had a good, do we have something of the sample test? Anyway, we'll talk about that sample test in just a second. Let me go and get today's session underway. Yeah, let me talk about that test. Hopefully I've got my problems worked out with it. So it was pretty stormy here. This is what it looked like yesterday, looking out over the bay. It's right now nice and sunny and really nice out. There's some nice waves, but they're not stormy waves. They'd be good to play in. And so this is looking down just below me, where the waves would hit. You can see all kinds of debris. It's mainly seaweed and that sort of thing would go flying into the air. It's quite spectacular. And then this morning, little Dora, the explorer, she went down to the beach to see what things were happening. And say, anyway, it was stormy even this morning, and it's really quieted down in the last little bit just now. I hope everything was good where you were. As I said, I understand there is a small power outage somewhere in the south end. The university is functioning, but I know some students have emailed me to say they can't. So let's get moving. Oh, yeah, I've got announcements to do before I get into this stuff. And they're not in my slides. Let me back up here. There we are. Okay. So there is a sample test that's posted. I don't know what it looks like when you go to do it. The question order is supposed to be randomized. So I don't know if that meant the short answer questions were mixed in with the multiple choice. But it should be along the lines of what I'm going to have you do on Friday. That if you had problems getting in or using that test, please let me know. I'm more concerned about technical problems like Ashley asked Excel. No, I forgot to put that out. Although Chapter 2, which includes stuff on Excel, generally I try not to put Excel questions in a test. We'll see with Test 2 how I'm going to handle that. But the I don't want to do an Excel test, about, well, what's an approximate match compared to an exact match in Excel. I'd rather, in the assignments, I'm going to try to have you do those sorts of things and demonstrate it. But having Excel questions, there's bigger chance of things going wrong, and especially when I put a time limit on there. So I've still got to work out what I'm going to do with test 2 and maybe even test 3 that will involve stuff that is less sort of theory, I guess, like we've been doing, and it's just hands-on Excel stuff. So we'll have to sort that out. But for your test, no, I've taken out anything to do with Excel. I think I'll double check. In contrast to the questions in the quizzes, you would see feedback immediately if you got the right answer or not. And in the test, you don't get that. And you won't during the test. But I got to see if I can turn it on for the sample, because some of you have asked, you've done the test, but you don't know if you had the right answer. And it's awkward for you to go back trying to check through the book to see, did I get the right answer? So I'm going to try to find a way to turn that on. That the sample test, I've got it turned on until Saturday or something. That unfortunately, and there's no point values in it, so it doesn't go into gradebook. So even if I turned the test off so you could see stuff in gradebook, you wouldn't see any grade because all of the questions have 0 points associated with them. Anyway, we'll see what, I just wanted you to see what examples of questions would look like. I should put out for you sample answers for the short answer questions in particular. What sort of thing would I be looking for? Let me try to get that out later today after I've got a class after yours. That even though you got a test on Friday, remember you still got quiz number 3 on Saturday. Every Saturday there is another quiz. And you can always do them early. And I know there's at least 20 or 30 students who've already done quiz number 3. And I'm going to try to have assignment 1 posted tomorrow. I'm doing data cleanup right now from the survey and trying to, the 2 surveys, last year's and this year's, had lots of questions in common. Last year's had more other questions, which I'll suppress. I've got to clean out. They were administered through 2 different types of software. So the way responses, even to the same question, are recorded are different. So that's where I am at the moment, trying to get them both in the same format for you. I don't want you to have to do too much cleaning, and any cleaning that's beyond what we've done within the class. And office hours. If anybody's been looking for them yesterday and today, they haven't been. I've got to get Zoom up and coming. I'll try to get that alive tomorrow because there may be questions, particularly about the test, that you'd like to be able to ask during the office hours. So I will try to get that alive tomorrow morning. And I think that's it in terms of announcements. Any other questions about the test or anything else before we get started today? The test is the main one I worry about. And if something goes wrong for everybody or just for you, we'll work that out. So don't worry about the test. Worry enough that you've, oh, when's the sample test due? And power just came back. Well, welcome back. The sample test is due anytime, whenever you do it. As I'll try to make the answers visible, or I will post them in a separate document. That may be the easiest thing, is I'll just post a document that is answers to the sample test. How's that? That'll work better. I should be able to prepare something like that this afternoon. So yeah, you can start at any time, Giselle. I'm going to set it up so that it starts anytime after 1 a.m. Atlantic time and has to be completed by 11 p.m. Atlantic time. So you've got 22-hour window, but during that window, once you start it, you'll only have 45 minutes to finish it. And we'll see how that works out. Hopefully everything worked okay. But I'll be around Friday, hopefully answering questions. Oh, no, I may be on the move between here and Halifax Friday. So there may be long gaps where I'm not on email. But is the sample's not worth anything, but the real test on Friday is worth 6 points towards your final grade. Okay. So let's get underway. And if you've got more questions after class, send me emails. I'm going to try as much as possible to keep up to date on that. So last day we looked at preparing a data file, and we got it into a data table. We used VLOOKUP to go and do some recoding. We renamed variables. We had some problems in doing that because when we recoded blanks for gender, they came up male and had to create an if statement so that it would keep a blank a blank. You have to watch out. When you recode things, it makes it easier, but it may end up being such that you can modify your data in a way you didn't intend. So be careful as you're going through with that, and always keep going back, looking after you've made a change, what happened? Did it change the way you wanted it to? And from data science perspective, it was about, the importance of protecting your data the importance of a data dictionary to understand what it is, and that there are probably data quality issues in any data set, so don't be worried about that. That the lecture, Ashley, from last class should be posted, and I will post today's lecture as well. That I've also modified uh, the chapter 3, and I've inserted 2 videos in there that cover last class and what's in today's class in terms of activities in Excel. So there's a little bit, oh no, the one before was from chapter 2. There should be some short how-to videos in there. So today I want to explore, for the most part, a single variable. Generally, I'm fascinated by patterns, and for patterns I need several variables, but uh, generally we'd start looking at each of our variables to see what does it look like? What sort of answers did we get? And then we may start drilling in and we'll look at subgroups. So is the pattern different for business students than art students and science students? And we will start getting into what are called descriptive statistics, something that would be taught in a stats course, at the beginning of a stats course. So hopefully you'll be seeing this again when you take stats, that maybe you'll even remember it for when you take stats. It should help you anyway. So I'm going to go and use that student survey data. I'm going to use the day 4 spreadsheet, and I should have posted that. I should have posted the spreadsheet the way it looked when we were finished it after the last class. May have been slightly different from what you saw because I did it 3 times for each of the different sections and may have finished it off slightly differently before I posted it. But after we did all the recoding, we were able to see things a lot simpler. We could see, with a student that this student 472 was a first year student. She was in business. She was from Nova Scotia. She had very low salary expectations. She was a female student. She wasn't sure about her parents' education, and her first language is English. So it makes instead of these numbers and codes, makes it easier to read. But if I go back here, I'm going to bring up Excel in a minute and leave my PowerPoint. But a lot of the details, like last time, are in the PowerPoint, although I don't follow all of them. You'll see that there's these little arrows up here, and we didn't pay much attention to them last time, and today we're going to be using those a fair bit. Okay, and so let me go and switch over to Excel and oops, no, those can't be showing you your test. There we are. Okay, here's the data we had last time. So this is what I just had appearing here. Oh, actually, it's missing year. Yeah, so it is a slightly different. I didn't put year in here in the table for it. Do I have that in my lookup tables? Curious. No, I didn't. Oh, okay. So this is not quite the way it should look. I think the one you've got, though, has year in there. So I've got all of these different things, and today I'm going to be paying a lot of attention to salary. And I want to look at those numbers and see, are there patterns to them? So there are many different sorts of things that I can do that the I want to make sure I'm consistent with the sequence of my slides. Excuse me. Can I go back there? So I'm just going to look at business students, and then I'm going to look at a subgroup within that. So where am I here? So here are all the salary figures. They're all jumbled. I have all kinds of different students. Why don't I start out by just looking at business students? So I clicked under program, the down arrow, and you see a whole bunch of checkboxes. So I'm going to click select all and turn them all off. and then I'm just going to click business. So these are only the business students. So it's only business students. Here are their salary figures. Okay. Maybe I just want to look at international students that are in business. So I could go over to home and I'll click that off and I'll just look at those from outside Canada. Okay. So these are their figures. Oh, there's someone that wanted $200,000, 100,000. They tend to be big numbers. I've got a few gaps. They're showing up here. They didn't give me what they earned. If I only wanted to look at females, I could go over here and here's gender and just take the females. My data set's getting smaller and smaller and smaller. If I wanted only first year students, I can't actually get that because my file here, I don't have, well, I could go and look at those that started in 2009. You may notice, if you can see this, that those numbers should go from 2002 to 2009, but I've already stripped it down to business students outside Canada that are female, and there are none of them that started before 2005. So the list of values will change and your selection will change based upon previous filters. So I could just say those in 2009. And I've got a smaller list. Ooh, hey, excuse me, I've got a row here that shouldn't be there. Let me just, I thought I cleaned that up before class was, okay. So now I'm down to a little tiny group. These are first year women from outside Canada studying business, and here are their salary expectations. $800. That must be a typo. But they're 4,000, 2,000. Strange. So if I want to look at subgroups, I can do that type of thing. And if I wanted them only in a certain range, I could even do that. So if I look at salary, it's a number. The others were all categories, and you'll see here all the numbers that I've got left. And I can filter by color. You can actually color code things. I'm not doing that. But we have number filters. So I could look at only those equal to $50,000 or not equal to a number, greater than, or equal to. Say I want only those that are between 20,000 and 100,000. What's that? 100,000. And so that'll strip those out. It took out all the blanks. So I can filter on words, I can filter on labels, on numbers, and there's a lot of flexibility there. But I'm going to get rid of all of these, clear these out. Whoops. Let me clear that filter. So if you go up here, there is a button that says clear filter. And see, start here. That's another one. I don't know how to clear all the filters at once. Well, there is a trick for doing that, but it's messy. I don't want to mess everything up that way. Okay. And actually, I can't see you. So if you've been asking me questions, I can't see them. Oh, no questions. Okay. So now I can still see chat. Hopefully you can still see chat and you can question me about these things. So filters, we're going to use them in a minute for other applications, but they're nice ways of being able to slice up my data set to look at specific subgroups. And so I can filter on many different things all at the same time. With filters, it doesn't really matter what order I do the filtering in, because it's only, I looked at business students from outside Canada that were female, that were started in 2009 and had salaries between 20 and 100,000. That was the sequence. I could have started by filtering on salary, then gender, then year of study, then program, then home. Uh, it doesn't matter. Another thing, though, that we can do is sorting, and sorting, it does matter. If I went up here and I wanted to look at, let's just look at numbers as an easy one. So suppose with the salaries, I wanted to sort smallest to largest, and I like doing this. I like sorting because it gives me an idea of I've got 5 people that gave me 0. They didn't leave it blank. They gave me a 0. I got a 500, an 800, 2,000, 3. I like looking at what are the small numbers looking like. Then I've got 800 values. So what are the ones in the middle? That's around 400. So they're around 50,000. What are the big numbers looking like? They're down at the bottom here. Oh, yeah, we've got a lot of blanks too. And I've got some crazy, crazy numbers here. Some that are really big, but there's some, so it's just a small number of very crazy ones that I'm not sure. Those are probably typos. And then down below that are all my blanks. So I can do that type of sort on that type of thing, but I can do other types of sorts. Like I could sort on, here's words, and I could sort alphabetically. So arts, then business, then so on. And you may find that within that group, notice that the salaries are sorted in order. So that in this instance, that sort order is important. That you've got to be careful here with it. Generally with sorts, I don't like to do it in this fashion, one by one. I go and use, I know it says sort by color, skip the color bit. Down below it says custom sort. So right now I've sorted by program from A to Z. Within the program, I can have it sorting by where they live. So all the art students and then by their homes. Then I could do it within those communities, maybe what is their salary expectation. So I can change these. These can be smallest to largest, alphabetical. That I can do it in different sorts of ways. And so, boom, I do it this way. These are art students. The ones from Alberta come first, then British Columbia, then Manitoba. And if I look across here, I've got what their salaries are, and they're for each of these groups in ascending order. That was blank is the last one in that group, and then next group, and then the next group. So I can do all kinds of interesting sorts of sorts by doing this sort by color. Whoops, filter, no, sort by color. And it's, as I said, a custom sort that if I wanted to change the sort order, I can either go and change it here, or I can move things up and down with these arrows. It's a very flexible tool. That the problem I have with it, and I make some mistakes with sorting, that the and I'd like to get back to where I started from, and that's where I like having the ID number, because when I started, I sorted by the ID number. So I'm going to sort my IDs smallest to largest, and this gets me back to the start again. So this is my original spreadsheet. That if I didn't have the ID number, I wouldn't be able to get it back looking exactly the way I started. And there's sometimes we need to do that. We'd like to reverse all the changes we made, like me clearing my filters out. I'd like to clear my sorts out. And if I don't have an ID column, and if I haven't started with the IDs being sorted smallest to largest, then I run into trouble. Now there's another piece that I like within this table, one other piece. And let me go into my table. And when I'm clicking in the table, I get a tab up here called Design. Go to Design. And these are different things to do with the style of this table. So if I wanted it to be in orange instead of blue, if I wanted, I've got banded rows here. If I wanted each column to be a different color, I could do that. There are all kinds of different things you can do. But I like having a total row. So it just threw me right to the bottom of my table, and it put a row in here, but it's blank. It's put a line above it, but it's blank. So what does this mean? Well, if I go and click on it, I get an arrow. And when I click the arrow, I get different functions I can put in here. I can count. I've got 811 ID numbers. Great. That's how many students I had. I look here, click count. 802 told me the year they started. And if I click here, count, tells me 803 told me their program. Well, if I click here and do count, I get 811. What happened? That this is the same as that. Well, watch it when you're recoding, because when you do that, I've got a blank somewhere here. There we go. Here's a blank for program. It's now not applicable. So after I recoded, it put a value in there. And so you be careful when you're doing that. Your counts may be incorrect when you do it. And even watch it with gender. I go here. Where's my arrow? Oh, wrong place. There it is. 665 told me their gender. And then if I do it here, blanks are blanks. Good. If I count, I'm back to 811. It's now counting those blanks as being a value. Confusing. I don't know any way around that. There probably is a trick, but I haven't figured it out yet. So I recoded this so that a blank, this being blank, got changed to a blank, but it now treats this blank differently from that blank. These ones here are numbers, and that's probably why it may be doing that. But again, be careful. Why did only 665 respond that way? It was probably they were tired of answering. We'll get to this. Let me make sure I'm on track. So let me go back to slides. So I did my filtering on business, and then I got all the business students. Then I picked international ones, and then I picked females. And I must have been using a different version of this spreadsheet. So I can do lots of different sorts of things. And then I just did sorts. And we had all kinds of strange numbers we can see within our sorts that, and yeah, it raises data quality issues. It generally your problems with numeric values are at the beginning and at the end. And so take a look at those ones. The ones in the middle are the ones in the middle. They're generally not a problem. That the blanks generally are an important issue, but I just found that out by looking up count. And we just did a total row. Okay. And, oh, okay. I'm supposed to go and give you averages. Let me go and show you about averages. So let's go back to salary. Where is salary? Okay. So in salary, how many told me their salary? 752. So I'm missing about 60 students. 59 students didn't give me a salary figure. Of those that answered, So these blanks aren't zeros. What is the average of them? And the average salary was $52,914.80. If you want to format that, you can do that as a dollar figure. I wouldn't fuss with formatting. So that's the overall average, but we know that there are strange numbers in there. So we could go and filter at the same time. So here's my average. So I could go up here and say, I'd like to filter, and I'd like to take out the crazy numbers. Say I take out the numbers between, I'm only going to look from 20,000, that would be minimum wage, up to 120,000, which is a crazy big number. Oh, the number's a little bit smaller, but not changed an awful lot. So maybe that those values like 650,000 or 200,000 and so on are not inflating my average too much. I also filtered out some crazy small numbers, and maybe on balance, it's about the same. That the, let me make sure I've got things. The, what else can I get out of this? So let me take my filter off here for a minute. I'm going to clear the filter. From here, before I sorted and scrolled through, but I could have found that out, at least what the lowest number was. It was 0. And I could look up what the maximum is. That was the 650,000. I still like to do the sort because it gives me an idea if there are many other values at the beginning and at the end. So Esther, I'm switched out of the PowerPoint and I'm just playing around with Excel. It's summarized though in the PowerPoint, but if you've got questions afterwards, get after me. So I'm looking at doing different things with my total row and what's interesting in it, and that I can also use my filters at the same time, filter on this or filter on anything else. I want to put my filter back on because I want to try a few other things. Oh, I want this filter on, these crazy numbers. So that's still maximum. I want average. Okay, so the average is around 51,000. Maybe I'd like to know, I'm going to make this a little bit smaller so I can see columns across here. Okay, let me make it a little bit smaller again. I hope you can still see this. I'm going to go over to program, and I'd like to know what's the average for business students. I would think they probably expect to earn the most. And there it is. Business students expect to earn on average just 52,400. So it's not much different from the others. Um, so, and there's 271 of them. Oh, that's good to know. Art students, what do they think they're going to earn? 47. We got a lot of them too. So art students expect to earn a lot less. What about my science students? Whoops, no, I picked the wrong one. I've got my art students still there. Just the science ones. Science expects to earn $57,000. So science grads expect to earn $10,000 a year more than arts grads. And they expect to earn significantly more than business grads. Um, they're wrong. Um, despite the attraction and the hype that's associated with science programs that the government keeps pushing and industry keeps pushing, science grads on average everywhere in Canada earn about the same as arts grads after they graduate. that unless they go on to graduate degrees, and then that's a different thing, and they're looking at their graduate salaries. Business grads do earn more than arts grads on average, and science grads on average, but it varies, from student to student. So we can do some basic exploration of our data by going and looking at this total row, and by looking at filters, by sometimes doing sorts, those sorts of things. And I'm going and getting back to my original data set here. And I'd like to do some other things to it. So let's flip back to our slides, back to the slides. So this is what I did before when we found the average was 52.9, and then I filtered and got it down to 51, and then I cleared that filter. I played around with counts. Oh, this is some of the stuff we did before, and that just the lessons you learn by exploring counting is that you may have made mistakes, or you may have changed things you didn't want to. You also start seeing patterns. I look at the counts for each question from the beginning of the survey to the end, and generally we find that they start dropping off. Sometimes if it's a long survey, there comes a point that almost everybody seems to drop out. It's not a good idea to have a long survey. That we looked at minimum and maximum, and then we looked at averages for arts and business. And so I can do all of these sorts of comparisons. They're tedious. We'll see other ways of doing some of these things soon that are broader in terms of what we can do. But these are the basics that we might start doing before we get really deep into the data, just to get an initial feel as to whether or not we've extracted the data correctly or coded it correctly. That are there any alarm bells ringing? But now I'd like to get into what's covered generally in a statistics course of what they'd call descriptive statistics. That sample test disappeared. Okay, well, we'll figure that out. Descriptive statistics is, in a statistics course, they have statistics are measures, averages, those are measures, those are called statistics, and other types of things that summarize data. And most of a traditional stats course, like you would take after this one, look at inferential statistics, like trying to describe what others would look like besides those in your sample. But describing what's in your sample is just called descriptive stats. And so we've sort of been doing that. We've been looking at averages and maximums and minimums and that type of thing. And there are a variety of different tools for doing that. And we're going to look at one that summarizes things, takes my 811 values and shrinks it to a smaller number of values, but doesn't just reduce it to a single number. It still gives me a sense of pattern. And so to do that, I'm going to have to use a tool set within Excel. So let me go back to my Excel spreadsheet. So I've got this as my spreadsheet here. Go up to File. This is on a PC. On a Mac, it's different, and I can't remember how to do it on a Mac. I don't have one. So I went up here, and I get a list of things, and one of them is called Options. And then it brings up a screen, and it has a list of different things I can do. And one of them is called Add-ins. If you did Quant 1, you may have gone through this process. That then eventually down here, it has a box at the bottom that says Manage Excel Add-ins. Click Go. So if you did Quant 1 at St. Mary's, you use the Solver add-in. I'm going to now use the Analysis Toolpack add-in. So I've already got mine installed. I'd click OK. And if I go up to my Data tab up here, then it'll have over on the right-hand side a thing called Data Analysis. And this is what we're going to use. So what I'm going to do is take the salary data and I'm going to try to group the salaries together in a pattern. Let me just go back to my slides for a minute here to show you what I mean so I've just installed this. Now, I'm going to create what's called a frequency distribution and then a picture of it, which we call a histogram. So a frequency distribution, we did that, well, we sort of did that. We created a lookup table that looked like one last class. So I could take the different, remember I created salary groups. And now last time I called it up to 20,000, then it was 20 to 40, 40 to 60, 60 to 80, 80 to 100, 100 and above. And I could have gone through and I did this. I worked, well, how many fit into these different categories? This is a frequency count. And it's sort of nice. It tells me that there's a small number, relatively speaking, that had very low expectations and a small number had crazy ones. And most were in the middle here. We had a few that were more than I would have thought on the very high end. So, but it gives me an idea of how many were into these different categories. I did this manually. How would I do that automatically? And Excel can do that for us. It's crazy to be able to do this manually. In a stats course, they would probably make you do it. And so before I used VLOOKUP to do this, I'm going to use a function in Excel for doing it. It's clumsy, actually. I'll show you it because you'll probably see it in your stats course to use it. But there's actually better ways of doing this with more functionality, and we'll see that in another week. So if I was to build a frequency distribution, if I was going to group the salary data, I just did a grouping. I could have grouped it different ways. I did 0 to 10, 20,000, 20 to 40, 40 to 60, 60 to, and so on. But I could have grouped it differently. Why did I pick those ones? Is that a good grouping that I used? Generally, we're trying to summarize things. So summarizing means we want it to be concise. But the purpose of summarizing it is to make it informative, because the raw data just wasn't informative looking at it. So how do I compress it down but not lose too much information? And so I put a discussion question in here. Hopefully it works. I hope the discussion works for you. I put this in because I want to see, some of you have been saying, quite a few of you, that you can't participate in the discussion. It doesn't work for you. If it's not working for you, can you make a copy of the screen, take a screenshot, and email that to me? And I will be sending that to Top Hat. They've asked to get a screenshot of what your screen looked like when it wasn't working. And if you'd do that for me, I'd much appreciate it. Any thoughts about what would be a good summary or what would be a bad summary? Things we shouldn't do, things we should do, that they, what are best practices? There isn't a single best practice. Many statistics books tell you one way to do it. It's not right. You can do it all kinds of different ways. It's a communication tool. And so there are different ways we can communicate, and sometimes more effectively than others. Anybody have any thoughts? Clock's ticking. No? Okay. Nope. Clear and easy to read. Yep, definitely. So that's maybe in the formatting of it. But easy to read. Easy is a good word. What's easy to read for you? No useless stuff. Again, there's no clutter. There's no extra stuff. So, okay, there. Not too many groups and not too few groups. If I only had two groups, if I said, okay, students that pick numbers between 0 and 50 and those that were 50 and above, that's too compressed. If I made it into 100 groups, that would be way too many. It's not concise. Um, that um, they, I'm not sure. Okay, Giselle, yeah, okay. We'll get that. Everyone fits into a group and only one. Exactly right. That's really important. We want to include that. You've probably done this before, eh? Contains all the information, shows it concise but comprehensive, right? Um, yeah, I'm going to jump. It's precise and accurate. Uh, Tricky words as to what you mean by that. What was the last one? It was organized. The last one was. So these are basics about how to present stuff that are, some of your comments there are a little bit more generic than having to do with frequency distributions. I'm going to jump ahead just to keep us on time. So don't have too many, it's not concise. Don't have too few, I lose too much information. They should be unambiguous so they don't overlap. Everybody fits into only one group. It should include all the data. So you said all of those things, which are standard sorts of things. I have other requirements though. Use nice numbers. Not all numbers are the same. I wouldn't have groups that go from 0 up to 13,000, 13,000 to 26,000, 26 to 39. Those are not nice numbers. We like, when we pick numbers, if I ask you pick a number between 1 and 10, you might pick 3 or 5, something like that. You wouldn't pick 3.1417. Uh, it's not a nice number. Generally, they're multiples of things like 5, 10, 25, 100, 1,000, something like that. And also strongly recommend you go with equal size groups. We can build them with other size groups, but then comparisons get to be awkward to do. That if very high had a range of 80,000 to 120,000 instead of 80 to 100, it's twice as big a group as the other ones. And so how do I compare them? There may be a lot of students in the group because it's a bigger group. If they're equal size, it makes it easier to compare the groups. But think about it. I've got values up to 650,000. If they were all equal size, say in steps of 50,000, and I had 13 groups, I'd have almost everybody in the first 2 groups and almost nobody in the remaining 11 groups. That doesn't work. So generally what we do is if we've got some stragglers at the top or stragglers at the bottom, we make the first or last or both to be like the last group would be $100,000 and above, and do that type of thing. That's what we did before. Our last group didn't have an end point to it. And so that's what we're going to try doing. And we're going to do it in Excel, and it's going to involve something that looks like a lookup table. So here I got to create what they call bins. So let me get back into Excel and I'll show you. So here are the values I've got. I'm going to create a new lookup table in a sense. And I'll give it a name. I'll call it salary bins, but it doesn't matter. You can call it anything you want, or you don't have to call it anything. You just have to be careful about labels. If you're going to use, either you always use labels for everything or you never don't use labels at all. And I'm going to use, I could make my groups look like, say I went in increments of 10,000. So I went 0, whoops, and then 10,000. And then the next group goes 10,000, oops, that's 100, 20,000. And then 20, 30. Like we saw with VLOOKUP, I'm repeating myself that if this one ends at 10,000, the next one has to start at 10,000. If this one ends at 20, then this one has to start at 20. So I don't need both. With VLOOKUP, we just use the first number, the 0, the 10,000, the 20,000. Those would be my categories if I was going up in steps of 10,000. What I find frustrating is in the histogram function in Excel, they want the top value, not the bottom value. So I'm just going to keep these ones and just going to save myself a little bit of typing. So I'm going to go 40,000, 50, 60, 70, 80, 90, 100, 110, 120, and that's as far as I'm going to go. I'm not going to keep going. I'm just going to ignore the rest. It's just too much work. As you can see, I've done it in increments of 10,000. You can have them in increments of any amount you want. You can have different increments, but I don't recommend it. I strongly recommend you keep each of these exactly the same. Okay, now I've got it ready. Let me go back here. So at this stage, I am going to go to Data Analysis, Histogram. Oh, hold on, let me get this stuff out of here. I'm not sure why it's jumping around on me. Don't worry about that. It'll go back where it's supposed to. Okay, so, and I'll take that off. So to start out with, I need to give it the input. Where is the data I want to summarize? And I'm going to summarize salary. So I could go and just grab this and zip all the way to the bottom, but it's a long list. And in fact, I'm going to want to keep the labels. So I know it's in column L, and it goes to L812. The bin range, I just created that in a lookup table. So I'm going to jump right over to my lookup table. And let me move this out of my way. And here are my bins. Okay. I've got labels on both on the salary and on the bins. Don't have a label. If you have a label on one, you have to have a label on the other. Oh, there, it threw me back. I always click on new worksheet, or almost always, because I'm going to get some output and I don't want to clutter up my data file. Sometimes I'll put it in the same place because I've got a specific application I'm dealing with, but most of the time I put it into a new sheet. And then down here, I want chart output. Don't use the other ones. I wouldn't bother about them. And then click OK. And it's going to jump into a new sheet. And let me make this bigger so we can see it. And here's my frequency distribution. I can change the labels if you want to change that. That's not a problem. So I've got my salary bins, and we know that this means 0 up to 10,000. This is 10,001 to 20,000, 20,001 up to 30,000, and all the way down. And then this is more than 120,000. So Excel will add in a group on the bottom called more if their value is beyond your last group. And sometimes you don't know where the last value is. This is how many fit into each of those groups. So these are my frequency counts. Okay? So this has generated a frequency distribution for me, and it gave me a graph. So I want to look at the graph. The graph is a column chart in Excel. It's a standard column chart, and you can do, if you've used charts in Excel before, you can play with it in the same way you can play with any other chart. Oops, excuse me. Do that. So there's different design things you can do, different format things you can do, and so on in those charts. and I'm not going to spend any time on that. But I'll just show you some things that would typically be done just for good practice. This, I'd give it a name, a frequency distribution of salaries. Oops, not sure how to leave me alone. Whoop, did it not? There we go. And so I got a new title I put in there that, let me make this bigger so I could see things better. It says frequency here and it says frequency there. It's just because of this type of chart. I don't need this. I'll get rid of it. It gives me a little more space. You can leave this as salary bins. You can change the words here if you want. But when you look at this chart, this one here under 10,000, above 10,000 represents from 0 up to 10,000. The second one is from 10,000 to 20,000. A column chart normally in Excel will have gaps between the columns. It makes it easier to read. But if we're trying to demonstrate that this represents values complete anywhere from 0 up to 10,000, we shouldn't have gaps. And so many people will recommend that you get rid of the gaps, and that's easy to do. So go and click on a column. Okay? Any column will do. And now right click on the column. So I'm right clicking to bring up what I can do to it. And there are lots of different things I can do. I'm going to go to Format Data Series. And it brings up a little piece on the side here of what I can do. And one of them says gap width. I don't want a gap. I'm going to make it equal to a 0. Hit enter, and all the gaps disappear. And this is my frequency distribution in a graphical format. It shows I've got a few at the bottom. Here's where most are. I've got a few at the top. So it's summarizing my data. I don't have 700, 800 values anymore. I've got them bunched together, but I can see the pattern graphically. Here I could see it in the table, but a lot of people like graphs better than tables, that they can process information a lot more easily. I found when I used to prepare reports for senior management at the university, my tables, nobody read them. And so I started moving towards using graphs. And when I used graphs, they paid attention and they'd respond and ask questions. But if I gave them tables, their eyes got blurry and they didn't understand what was going on. So, and we'll be talking about that later when looking at how to communicate information, even to yourself. Many of us find pictures work a lot better than tables do. But watch this one. See this guy at the end? More. It isn't, notice it's the same width as a bar as all the others. And that's what happens with a column chart is every bar, every column is the same size. So even if the group represents a huge range of values, it's the same size group. So this really represents from 120,000 up to 650,000. That's several computers away from the end of this thing. This is, and it looks like a bunch of people, but they're so spread out. They're what I'd call outliers, and you shouldn't pay too much attention to them. Don't let them distract you. So where am I now? Let's go back to my slides. So I did that. So I created those salary bins. I went and used data analysis to open that dialog box and fill in where the data was and all those sorts of things. And then I built my histogram like I just had. And I've just shown you how to get rid of the gaps. Okay. And warned you, don't be distracted by outliers. We frequently do get distracted by them. Don't pay attention to those things. And someone might be trying to draw attention to it. There's probably something wrong with the data, and don't worry about it. Now, I'll show you a few things, and I'm not going to do them in Excel for you because it gets really crazy. But if I went and said, well, let's just filter those out and then built my histogram, it won't work. I can show you quickly. Let me do that. Let's go back. I'm going to go apply a filter on here. I'm going to number filters. I'm going to get those that are between 10,000 and 120,000. The only on numbers that make sense. Get rid of all the blanks. And I'm going to go and do a histogram. There it is, histogram. I'm going to tell it my data is from here all the way down. Whoop. There. And I've got the same, everything else the same. And I click OK. Same picture, same frequency count. I've still got these 9 here. I've still got 22 that are down there. I don't know if you can see that. Maybe make it bigger. Pick the same data, almost exactly the same data. That what happens is that histogram does not recognize filters, doesn't recognize any type of filter. So if I just wanted to do it on art students and do a histogram on art students, I can't do it. Not easily within Excel. Because if I filter out all the other students I don't want, and then when I capture this column, it grabs everything in the column. It doesn't filter things out. So what do I do? Well, it's clumsy. I'll tell you how, but I'm not going to make you do that type of thing. I don't think. So what I end up having to do is filter, get the data I want, then I copy that data, put it into a new sheet, and then build the histogram on the new sheet. So it's a lot of extra steps. And sometimes we have to do that. We have to identify the data we want, copy that data, put it somewhere else, and then do our analysis. There are other tricks we'll see that we can get around that for a number of different things. But generally with the statistical functions in Excel, you can't just filter that. So if I want to compare arts to business and see the patterns and so on, it's going to end up being awkward. But I'm going to show you what it looks like because often, and we're going to be doing this later, we want to compare groups. So what I did was I copied all of that data into a new sheet. I created a column of all the art salaries, a column of the business salaries, a column of the science ones. I made histograms. I pulled them all together and I created a giant frequency table. Okay? And I'm not going to make you go through the work that's involved in that, but that isn't unusual for us to go and have to do some other types of things. And so these are the same salary bins that I had before that I have lost some students because I threw out the ones that were not in arts, business, and science. And so I don't have everybody I had before. That of the low figures, 9 were arts, 9 business, science only 4. The ones in the middle, yeah, similar numbers of arts and business students, but only half as many science students. Comparing these things ends up becoming difficult because I've got 275 art students, 285 business students. So these two columns are similar in that they describe similar samples, but this column isn't. This is, less than half of the size of either of the other two. So the numbers are going to be smaller, except here the 11 is surprising. It's much more than arts and almost as many as business, but for a smaller group of students. I'd like that to be highlighted, that difference that's happening there. So generally what we have to do is change these to percentages to what are called relative frequencies. So I went and took each of these numbers here and divided by 275. Each of these numbers divided by 285. Each of these numbers divided by 108. So each are a percentage. So the totals at the bottom are 100, 100, and 100 because they're all percentages. And you will see here's that 10% of science students where it was only 5% of business, 1% of arts. I generally will remove decimals with percentages. I don't care if that's 3.1 or 2.8. It's around 3%. I don't need to know more precisely than that. And then I used what's called a clustered column chart in Excel to put 3 histograms sort of on top of each other. It's busy. It's hard to follow. Here's arts in blue. Goes up, goes down again. Here's the one in orange for business. It rises, it peaks a little bit later, and then it goes down a little bit later. And so that's what we saw before with averages, that business students expected to earn more than art students. And then here's the gray one. This is science, and it's on the same scale. And science students expect generally to earn more. It's lumpy, and histograms generally are lumpy, but we're generally looking for patterns, and this gives me the pattern in this histogram. That, but it's busy. It's hard to interpret at times, and we will see a different technique later when we're trying to compare several groups. Like if I was trying to compare 8 different programs, I wouldn't be able to. There's just too much within my picture. So as I said, we'll do that later, but this is common practice to make histograms. They're still one of the most popular tools, but they're awful for comparing multiple groups. But it's the tradition. Don't be surprised by looking at it. So what do they tell me? They tell me certain pieces of key information. It's not really the picture. It's where's the middle? Where are most of the values? What are the small ones? What are big numbers? Are there a lot of small ones or a lot of big ones? Are they scattered all over the place? Or are they clustered together? Do we have lots of stragglers? Is it skewed? Does it lean to the left? Does it lean to the right? Those are the sorts of impressions that we're getting. We're not using it to read out precise numbers. So it's shape. And we have certain classic patterns. There's the bell curve, which many of you think grades look like. They don't, never do. That this is one where there's values in the middle, some below the middle, some above, but it's reasonably balanced either way. And then we have others where it's not balanced on both sides. There's a tail that's a little longer to the left or a little longer to the right. We call this skewness. That don't worry about negative skew and positive skew or left skew or right skew. Skewed means it leans one way or the other. And just remember, well, is it have a tail that's long on the left side or long on the right side? But many people get confused as to what do you mean by positive and negative skew. Try to avoid the jargon. So those are some of the things that we'll frequently look for. If you were looking at grades, grades generally in a course like this one end up looking like a left skew. So this picture that's here on the left side here, where I've got a long tail and then a spike and then to the end. And it can even be pushed further over. It's because you can't get a grade above 100. Most students are between 60 and 100, but then those that don't do well tend to be spread out over quite a broad range. That income data, salary data, sales data, most financial data follows this shape, where here's where the bulk of the values are, but then you get some numbers that are really, really, really big. So we have a long tail to the right. And so almost all financial data has a long right tail. So this is where we're going to stop today. That looking at trying to summarize data, get it into meaningful groups, trying to understand where it is. And so we've done it with a frequency distribution or a graph called a histogram that we can look at some simple measures like minimum, maximum, average, and get that out of the table row. But grouping data and creating pictures often gives us a better sense of all the data, and though it doesn't give us any precise numbers, but generally when we're looking for patterns, we're not looking for precise numbers. Next class, though, I'll look at number summaries. If you wanted to summarize things, if I give you a test back, in any course, when you get a test back, your first question is, what's the class average? That you want to know, are you above average or below average? If you're above average, you might want to know what was the best grade on the test, know how close you were to the top end. Students that didn't do well generally don't ask what's the worst number on the test. They're afraid their score is going to be the worst one. But they still think about it. Am I at the bottom? And so we'd like to have other measures than minimum and maximum and average for what's low, what's high, what's the middle, and maybe what's very low and what's very high. Low and high might not be enough for us. We'd like more sorts of things in that. And are there other things that we should be looking at? Okay, so last questions that are coming in about the test. So what time is it on Friday? Yes, 1 a.m. until 11 p.m., as Giselle says. That I won't ask you on anything that's not in the textbook. I won't ask you on anything that has to do with Excel. Let's see. Oh, I think that's it. That's there. You will be limited to 45 minutes. Yeah, the assignment, I've got to get that out tomorrow. I'm just being held up by getting the data looking good for you to do, but no, so that you've got enough time. I would strongly recommend, with the material we did last class and the material we're doing today, and this be the case from here on in, is I want you, would I demonstrate something in Excel? Can you go and try to repeat what was done in the class yourself using Excel and see, can you do it or not do it? And if you run into problems, then I want you to email me so that we're all on the same page. It may have made sense to you today, it may not have made sense to you today. That review the text and the how-to videos, but if it looks straightforward, very often when you go to try doing it yourself, it doesn't work the same way. So try it right away. It also is a way of committing new information to memory better by practicing or applying it as quickly as you can after it's been introduced. You'll forget it tomorrow. So try to do it today. Giselle, is it pretty much like the quizzes? Yes, that the multiple choice questions should be comparable to quiz questions. I struggle to make up new ones that weren't in the text already and then make up another set for your actual test. But they should be similar in many respects. The only thing that's different is these short answer questions, because there's some topics that it's really difficult to make as multiple choice, and I'd like you to be able to write a couple of sentences. And when I say a short answer, I mean a short answer, just one or two sentences or point form, something like that. But that's all you need to do. So our time is pretty much up. That I'll see you again. Oh, in class. Oh, okay. Oh, that's just a reminder telling me my next class I got to get ready for. So I do have to let you go. You take care, and I hope you're successful on the test. If you're not, then it means I've got more work to do. Okay, you take care. Bye-bye.